in.
Sounds great.
Welcome, everybody. Oh, Dale's here. There's Sheila. Oh, we got her. Welcome, everybody. We'll just give people another minute to join in, and then we'll get started. Thanks. Okay, so welcome again, everybody. Thank you for joining us for our Beaty at Home. In fact, our last one of the season here. And we are going to be recording this session so that everyone knows. And what we'll do is we'll use the chat for questions as well. So please feel free to type in the chat at any time with your questions, and we'll go ahead and collect them up in there. So we'll get started. So this Beaty at Home is about rivers, and we're very happy and very lucky to have Dr. Eric Taylor, Rick, here. He is a professor of zoology here at UBC, and he is also the director of the fish collection at the Beaty Biodiversity Museum. And he also served for many years as our director. So my name is Nancy, and we've got Nicole as well here, and we will be facilitating your questions. So please do feel welcome to type in your questions. So let's get started with finding out where the museum is. The Beaty Biodiversity Museum is on the traditional, ancestral, and unceded lands of the Musqueam Musqueam peoples. And so we have this flag here flies at UBC, and it is the Musqueam flag for their community. And so we've got salmon here, which I think is a great fitting thing for this day. We've got the salmon above a cedar net, I found out. So a net woven from cedar bark, which would go across the river and allow smaller fish to pass through and catch larger fish. So I thought that was very interesting. I also do encourage you to visit the community's website, the Musqueam people's website. I put down the URL down there, and it's a great place to learn more about that community. So we've got where the museum is on a map. It's right in the center of campus as well. So you can visit us. We're next to the Pacific Museum of Earth, next to the Biosciences building. And also we are attached to the Biodiversity Research Center. So through here, you can see this whale skeleton, our blue whale skeleton, the largest animal ever by weight. And through the glass, you can see the research center. So together, the museum and the research center form the Beaty Biodiversity Center. And there's over 50 researchers working on different amazing topics such as ecology and evolution and many others about biodiversity. So including Rick, of course. So when you enter the museum, you see the skeleton hanging there freely, and you can go down the ramp to the bottom where there are actually over 2.1 million specimens. So the blue whale skeleton is one specimen, but there are many, many more. And they are housed in these cabinets. So they are kept safe, hopefully for hundreds of years more. And we've got them in different categories. So I'll just show you the categories here. You can see the 6 categories: the cow and tetrapod collection, the marine invertebrate collection. You've got the herbarium, the Spencer entomological collection, the fish collection, and the fossil collection. So this is what it looks like inside the museum. This is a map of those different collections here, with the blue being the fish collection. And this is what it looks like when you're underneath the blue whale skeleton. So again, if you do have questions, I'm going to really encourage you to type them into the chat. And right now I'm going to hand it over to Rick. Thanks very much, Rick, for coming to do this for us.
You're more than welcome, Nancy. Before I start with, first of all, thanks people for coming to this final Beaty at Home. A couple of things I wanted to mention before we start my actual presentation is, one is I wanted to congratulate the outreach and education staff of the BBM. I believe this is their 67th Beaty at Home. A whole variety of topics have been discussed, and of course the pandemic created all sorts of challenges for all sorts of people, and of course extolling the virtues of the museum and biodiversity for a long time without being able to do it actually at the museum was a huge challenge, and of course they met it brilliantly with this Beaty at Home series. So thanks to them, and thanks to everyone who participated, both in giving talks and in attending them. The second thing is I want to acknowledge the 108 Mile Golf Club and Resort in beautiful 108 Mile, British Columbia, in the beautiful Caribou. They are allowing me to use their wired internet, which should provide for slightly better transmission than the cruddy satellite one I have where I am now. And the way this is going to work is I have a brief 2-minute video to get us sort of in the mood about rivers, and then I'll have maybe a slightly longer 10 or so minute presentation on rivers in this book that I've written. And then I have a slightly longer 5-minute video at the end that will describe the book in a bit more detail and what it's about. And then I'm happy to answer any questions you have or hear stories that you have about your favorite river, because the book I wrote is only about 10, and I'm anticipating all sorts of angry emails from people about why they didn't do this river, why I didn't do that river. Which is great because everyone's passionate. That means people are passionate about rivers, but you'll get some idea of the rationale for the book. So let's start with the short video. Share sound, very good. Just to get us in the mood. Looks like Dale wants to come in. There we go. It'll start in a second. There's a few quotes here, so I want you to have time to read them. Okay, hopefully that got us in the mood. Oh, we don't need to see that. Now I'll start with some just brief sort of tidbits about what a river is and why they're kind of interesting and why I wrote a book about them. So what is a river? Well, a sort of standard definition is a river is a natural body of water that flows within a defined channel, usually towards another body of water. And usually that other body of water is the sea, but it can be, in many cases, another river or a lake. And of course, there are all sorts of different sizes of rivers, and they tend to have different names in the general sense of rivers: streams, creeks, kills, and they begin as a rill, which is something that I didn't really know. I'd heard the term. And this is what a rill is. This is a definition by Luna Leopold, a famous hydrologist. It's a trickle of water from rainfall or snow or ice melt flowing within a channel that is deep enough to prevent being obliterated by further precipitation or further snow melt. So you can imagine the patter of rainfall on a substrate, and if there isn't a defined channel and enough flow such that that flow is maintained in the face of this potentially obliterating further precipitation, then it's not a rill. This is what a rill is. And that's where all rivers start. That's the smallest, the first elemental structure that forms a river. So this is basically what a rill looks like. This is from a photograph from the Fraser Pass, where the Fraser River, the Great River of British Columbia, starts. And you can see that little tiny little rivulet, or rill in this case, that's starting from some seepages further above, which starts again from snow melt. But this is the first time the Fraser actually forms a defined channel. And you think about what the Fraser looks like in Vancouver to what it looks like here, you can see it goes through some incredible changes as it gathers flow and proceeds south and west. Okay, so the world's largest river is the Nile River. The Nile River, and you can see the statistics there. It's over 4,000 kilometers long. And a lot of people ask, well, how do you tell what's the biggest river or where a river starts? And that's kind of tricky. You can evaluate the size of a river by its length, by its average width, by its discharge, how much sediment it produces, or in some cases, how much biodiversity it houses. The world's shortest river is the Roe River. It's only 61 meters in length, and it's a tributary of the Missouri River, which ironically is the longest river in the continental United States. Now, any individual river is part of a giant network of streams that gather together each other to form the main stem river. Fraser, of course, is composed of myriad tributaries and little streams that all form this great river. Within the encapsulated landscape, so the water is flowing within this sort of encapsulating landscape. I tend to think of it as being entombed within the landscape. And we call these are known as watersheds or drainage basins. And watersheds are separated from one another by heights of land known as divides. And if you think about it, if you think of all the great large rivers of North America, which we'll get into in a second, why don't they all flow like one? If you imagine spilling a glass of milk on a table, it just sort of goes randomly gooshing everywhere. Our rivers clearly do not flow in that way, and that's because they're organized by this great structure of landscape and continental divides across North America. So there's seven major drainage basins that are defined by these 6 major continental divides. And here's just a cartoon, a drawing of by Derek Tan that shows the basic structure of one watershed, and the sort of dashed white lines represent the divide between an adjacent watershed. And here are the continental divides in North America. And we tend to think, people think, you say the continental divide, everyone thinks of the Rocky with the Cordilleran spine. This one here right in the middle, this is actually really technically known as the Great Divide, because all of these other divides are also continental divides. That is, they sunder the continent into a series of basins through which large rivers flow. So we have the Great Divide here, which separates all the rivers flowing to the Bering Sea or the Pacific from all the rivers flowing everywhere else, like the Mackenzie River here, flowing towards the Beaufort Sea and the Arctic. And the reason the Mackenzie doesn't flow to the Pacific is because of the Great Divide, and in fact doesn't flow to the Atlantic, although at one time it used to. If you read the book, you'll find out why that changed. This Arctic divide creates this flow towards the north, and it's rare for most rivers in North America to flow to the north. Most of them flow to either the east or west or to the south. So this divide produces the Mackenzie River flowing to the Beaufort Sea. And you can see these other ones. I'm not going to go through them all. The Laurentide Divide, the St. Lawrence Divide, the Eastern Divide. And of course, the Great Basin Divide is an interesting one because it's known as an internal basin. So it has rivers in it and lakes that flow internally. So in other words, they don't flow to the ocean. They flow sort of subterraneanly into the interior of North America. So that's kind of unique about that. It's got that circular pattern. So these are the great orchestrators of the flow of our great rivers. And you can see that the rivers I discuss in this book are shown here: the Mackenzie, the Yukon, the Fraser, the Columbia, the Sacramento, San Joaquin, the Colorado, Rio Grande, Rio Bravo, the Mississippi, including its great tributaries, the Ohio and the Missouri, the Hudson River, little tiny one, but speaks volumes in terms of its historical import, and of course the St. Lawrence River. And there are lots and lots of other rivers that have individual books have been written about and that could have been included, but you have to draw the line somewhere. And the point of the book was not to give an encyclopedic account of every single important river in North America. It was to select a series of rivers, almost as replicates, that each illustrated a unique way in which they interacted with humans and humans interacted with them, to make the general point about how important rivers are in influencing the sort of North American experience. Now, because we're a biodiversity museum, I should say something about rivers and biodiversity, although that is one of the elements of the book, but it's certainly not the overriding theme of the book. Is not rivers and biodiversity. It's one of the many ways in which rivers impact humans and humans impact rivers. But as I say, it is a biodiversity museum, and I would be remiss if I didn't point out that rivers are great generators and sustainers of biodiversity. And this is for two fundamental reasons. One is they represent environmental gradients. The Fraser, well over 1,200 kilometers long, flows from, basically has an estuarine component all the way up to the western edge of the Rocky Mountains. So a huge gradient in all sorts of things like altitude, depth, temperature, sediment load, biodiversity patterns, riparian habitats, turbidity, etc. And whenever we get populations of animals and plants spread over different environments, we tend to see things like adaptive radiation, this proliferation of different forms, each with ecological attributes suited to the particular environment in which they live. So rivers are great at generating this type of variability in all sorts of things, and not just fishes. They often contain many internal barriers, and you'll see, I'll show you some examples of this in a minute. Waterfalls and cascades and lakes that can separate an organism into two or more different populations, and that often tends to facilitate genetic divergence, adaptive radiation, etc. And to emphasize, I wanted to point out that although I work on fishes and I'm interested in biodiversity of fishes and rivers, rivers are known, can be great sort of barriers and represent ecological transitions for terrestrial animals as well, that have some limitations in dispersal from one side of the river to the other, as you'll see in a second. So these two things about rivers, and you can think about also rivers being isolated from each other, certainly for things like freshwater fishes or mussels or things like that, that are found in one watershed versus another watershed. They can't get across the divide, therefore they're isolated. And that divide might also represent different environmental conditions that can drive this adaptive radiation. The bottom line is contrasting environments either within a river along a gradient or between rivers across watersheds, plus the isolation that sometimes entails, promotes adaptive radiation and speciation. So here are some examples. The Amazon River has over 3,000 species of freshwater fishes. Unbelievable level of diversity of freshwater fishes in the Amazon River. And a very, very interesting paper just came out in Evolution, comparing the rates of speciation among the marine environment, freshwater lakes, and freshwater rivers. And here's one interesting statistic. Rivers house 35% of all teleost fish species, 35%. Yet the rivers and streams represent less than 0.01% of the total Earth's surface area. There's a tiny, tiny fraction of the Earth's aquatic Earth's habit surface area that is constituted by rivers and streams, yet they house an enormous diversity of teleost fishes. Amazing. And there are also lots and lots of species, particularly in Amazonia, of mammals and bird species that are found on different sides of a river. And the inference and a lot of the work that's been done has shown that the different gradients, the different environments on one side of the river versus the other, and the dispersal barriers that can sometimes also represent, is associated with high degree of speciation in those contrasting areas. And here are just some pictures to put to the words that I've just been mentioning. Up the top left, these are just two watersheds separated by a drainage divide. And you can imagine that one might be flowing to a more arid area and one might be flowing to a wetter area, and that can represent not only the isolation of those two watersheds for freshwater fish, say, but also contrasting environments. Waterfalls in the bottom left, of course, represent in many cases clear barriers to dispersal from upstream to downstream, which can generate genetic variability or genetic divergence between populations upstream and downstream. And sometimes the environments upstream and downstream are very different. They may have different predator compositions, for instance, that can select for different behaviors in the prey populations above and below those barriers. That can have the confluence of the Rio Negro and the Amazon, the classic sort of blackwater river of the Rio Negro versus the whitewater habitat of the Amazon basin. And the bottom right is just an example. You can see, it's a little bit obscured for me, but there's, again, a very nice paper came out, I believe it was in Molecular Ecology, looking at the role of river barriers in generating species of terrestrial animals. And this just shows, in the black is the Rio Negro, the white line going vertically is the Rio Branco, and the yellow is the Amazon. And there are these two species of barbets, a western form and an eastern form, that have different plumage colors, as you can see under the throat. And there's differences in song and behavior that result in a high degree of reproductive isolation between those two birds. And some of that is at least maintained by the separation represented by the Rio Branco, and perhaps the different colors, I've forgotten the details of the paper, might be selected for by different environments on one side of the river versus the other. So rivers are great areas to study the biodiversity of animals and plants, its origin and its maintenance. Okay, as you all know, this year, most of Western North America is in a very, very serious drought. So our rivers are under threat from all sorts of other things. And this is a drought map from British Columbia showing the sort of central interior of the Okanagan and a little bit of the Caribou, where I am right now, in either severe drought or moderate drought or abnormally dry. So, and this has been going on for several years, particularly in the Western United States. And of course, drought means that water flows are very low. And this causes all sorts of issues for not only people who rely on that water to do various things, but also on the animals and plants that rely on that water as well. And of course, this is a very, very serious problem. And this is an article that just came up from the Globe and Mail yesterday. So the US has just declared the first official water shortage in the largest reservoir in the United States. That's Lake Mead. That has you can see this, here's an image of Lake Mead here. It's got this giant bathtub ring. So that's full pool, as they like to call, where the top of that white line is, and it's 161 feet below that. It hasn't been this low, at least in the last 5 years, and they declared an official water shortage, and this is going to be very serious for people who use the water, and there's 40 million people that rely on the water of the Colorado River, and the Lake Powell upstream is no better off. The inflow of water coming in, which is required to build up the supply of water to distribute to people and to biodiversity, is about 30% of historical levels, just to reduce snowpack over the last winter, and this drought that we're in, lack of precipitation. And Las Vegas, think of this: Las Vegas gets 90% of its water from Lake Mead alone. So there are some very, very serious cuts that have been already issued to the various states in that area. So the 10 governors of the Southwest U.S. just wrote a letter to Joe Biden to declare an emergency owing to this drought and the critical reliance of people on rivers. Okay, at this point, I also want to remind you that on September 26th is World Rivers Day. And this is a celebration of all things great about rivers and their interactions with people around the world. It started actually as BC Rivers Day by Mark Angelo, and it's grown into this international event. And I recommend you go to the website and look about what's going to happen on this day. There are things like river cleanups and all sorts of virtual talks and things like this. There's also some opportunity to see some really great movies, including one about Mark Angelo that's called Last Paddle. I think it's 1001 Rivers and One Life. This guy has paddled in down through and on 1001 rivers in his life, and it's all across the world. So it's really got some great footage of rivers from around the world. So I encourage you to go to that website to see what World Rivers Day is about and how you might want to participate, contribute if you'd like to. Okay, so why did I write a book on rivers? The top left is me as a little spidgen, and I've basically been around them my entire life. My father was a bit of an amateur outdoorsman, and always had us in rivers, canoeing, fishing, swimming, doing all that sort of stuff. So I've kind of always been immersed in them and jealous of the things that could actually respire water, in water without an aqualung. And then, so it's sort of inherent connection to them throughout my youth is what I'm trying to say. And the top right is an image that's actually not of me. I was one who took the picture, but this is a stream in Alaska, Hansen Creek, that has, and the spawning run of this fish that we took has over 21 million views for 24 million views for some reason on YouTube. It's a terrible video I took, but people seem to like it. The point is that I started working on fishes as a professor, as a graduate student, and eventually as a professor at UBC. And of course, if one is interested in freshwater fishes, as I am, you have to know something about the places they live, which in large part is rivers. So I became much more interested in rivers as a sort of biological phenomenon. Bottom left is me fly fishing on the Wigwam River in southeastern British Columbia. So I've been an angler throughout my whole life. And if one wants to be even modestly successful at fishing in rivers, one kind of has to know a little bit about how the rivers flow, when it's important not to fish them, when it's important to fish them, that sort of thing. And I've been on several canoe trips with old friends of mine, and they're always on rivers because there's just something about the flow of rivers that attracts us and has attracted people for millennia. We have this inherent connection to them. And I guess the point I'm trying to make is that, so I've been around rivers a long, long time. And I always viewed them as sort of objectively, or through sort of a purely sort of scientific lens, or purely for hedonistic reasons. I saw them as habitats that fishes lived in. I didn't think of them, so they were providing something to the fish were the things that I was really interested in, or they were providing me with great joy in fishing or canoeing, this sort of thing. I never really thought of them in their own right until
Hey, Rick, you just cut out for a second, so we'll get you to repeat your last message there. You just cut out for a second, so if you just back up like 30 seconds.
30 seconds. Okay, I guess the last message I said before I got to that slide was that I'd always thought of rivers from a biological standpoint as somewhere where fishes lived, or something that gave me pleasure. I didn't think of them about having a history of their own, or how they impacted people more generally outside of my own little narrow view. And that's when I came across these two books. So I sort of got an interest in rivers, and I started reading books, and there's dozens and dozens and dozens of books about single rivers. This one on the left, A River No More, The Colorado River in the West by Philip Fradkin, was written in the 80s. And it's the story really of the construction or the total re-engineering, replumbing of the Colorado River with the construction of the Boulder Canyon Dam and of course the Hoover Dam. And the thing that really got me about this book was, it goes through it doesn't go through so much about the geological history of the river, it goes through a little bit about the ancient peoples of the river, but where it really gets interesting is how it describes the power of the US, particularly the Western US water lobby in Washington to lobby for dam development, irrigation development in the West, to turn this base area that's basically a desert, other than bits of Washington into an agricultural behemoth. Yeah. You hear about the power of the oil lobby, or at one time the cigarette lobby or the car lobby. Those people have nothing on the U.S. Western water lobby. Incredibly interesting. And what fascinated me about it was I had no idea that water could be so powerful politically. And it was the human interaction with the rivers and how that rippled through the sort of political landscape that got me really, really interested. So I started reading more and more books about how humans interacted with rivers socially, politically, economically, etc. The one on the right is by Hugh McLennan, Seven Rivers of Canada. And this was a centennial project, 1967, based on a series of articles from Maclean's magazine. And it's basically what it says. He describes 7 rivers of Canada. I'm not going to go through them all, but the Fraser, the St. John, the St. Lawrence, the Red River, the Saskatchewan River, etc., and tells a story about each one and how they're important in this thing we call Canada. So I said, well, wow, okay, so that was written in 1967. I think it's time for an update. And because of my interest in the book on the left, A River No More, I said, well, really, there's zillions and zillions of books on the Colorado River alone. There's lots of books on the Hudson River. There's, as far as I could tell, there was no book that looked at a set of rivers in the North American continent, in particular, that included rivers that were important to Mexico, which is also important part of North America, obviously. So I said, well, the McLennan book, that idea really should be updated for Canada, and it should be expanded to not rivers that made a country, as McClellan said, but rivers that made a continent. So that's how the whole idea started. And so this book is called Rivers Run Through Us, a natural and human history of great rivers of North America. It's, I'm lucky enough to have a publisher, Rocky Mountain Books, out of Victoria and out of Calgary, that's is publishing it, and it's coming out in October 2021. And with that backdrop, I'm going to show you the 5-minute video that describes in detail.
Hey, Rick, there was a dramatic cutout there as well. If you don't mind just repeating yourself again, it just quickly cut out as you were transitioning to that video. It looks like Rick's Wi-Fi might be a little bit spotty, so let's give him a second to catch up. In the meantime, did anybody have questions about anything Rick had mentioned so far before we get to that video?
Did the first video show well?
Yes, it did. I'm not too sure. There must just be one other person on your on the internet. So looks good now. Feel free to get started whenever you are ready.
I think the video is self-explanatory. It's going to tell you what the book's about.
Humans are naturally drawn to rivers. We are a riparian species. We live along them, and we depend on rivers to sustain our lives, our livelihoods, and our well-being. It is no surprise that the Fertile Crescent, the cradle of human civilization, encompasses 2 great rivers, the Tigris and the Euphrates. Or, consider that today, 63% of all of humanity's 7.8 billion people live within 20 kilometers of a large river. Or that 93% of the world's megacities, defined as those with 10 million or more people, are built along great rivers. Rivers Run Through Us, a natural and human history of great rivers of North America, explores the relationships between 10 great rivers and the development of our societies since humans first crossed into our continent over 15,000 years ago. Rivers Run Through Us begins with an introduction to what rivers are and some of the philosophy of what drives the intimate connection between humans and rivers. Next, Rivers Run Through Us introduces the family of North American rivers and how they formed through massive ruptures in the Earth's surface, mountain building, and the great glaciations. The first of 10 great rivers explored is the Mackenzie River, encompassing 20% of the land area of Canada, with a delta consisting of more than 30,000 lakes. The river valley was the focus of a massive energy corridor proposal in the 1970s, and the inquiry into this proposal set the gold standard for consultative processes and was central to the ongoing evolution of Indigenous land rights in Canada. Next is the Yukon River, site of the last of the world's great gold rushes, and the collective lunacy that the riches of its Klondike River inspired. The Fraser River, the soul of British Columbia, is a sculptor of biodiversity within its basin, especially the myriad populations of its 5 species of majestic Pacific salmon. The Columbia River, builder of an empire, whose muscle was harnessed in the form of great hydroelectric dams that helped to address an unemployment crisis in 1930s America, and whose power was critical to the Allies' efforts in the Second World War. Next are the great conjoined Sacramento-San Joaquin rivers, whose waters transformed a desert into one of the world's agricultural behemoths, but at great cost to the biodiversity within their basins. The story of the Colorado River follows, a river sacrificed to the ambitions of humanity to build great cities in desert environments. A once idyllic delta now rarely sees any flow of water that originates more than 2,000 kilometers away, high in the southern Rocky Mountains. Steeped deeply in the history of relations between the United States and Mexico is the Rio Grande-Rio Bravo. Today, it forms 2/3 of the international border between the two countries and is a source of ongoing immigration tensions, including scores of drowning deaths every year resulting from attempted crossings of the river. The Mississippi River, Old Man River, the Father of Waters, the Big Muddy, a massive river system draining 41% of the United States. Control of the Mississippi, once referred to as the body of the nation, was the major strategic objective of America's Great Civil War, and the scene of one of its most decisive campaigns, the Siege of Vicksburg. The Hudson River is the shortest of those examined in Rivers Run Through Us, but what an impact it has had. It was crucial to the development of the world's greatest financial center, and its sublime scenery inspired the first great North American school of art, the Hudson River School of Landscape Art. And finally, there is the St. Lawrence River, the Fleuve Saint-Laurent. For thousands of years, it has been the gateway to a continent, the outlet for 20% of the world's fresh water. Its seaway transportation system moves the sea 1,000 miles inland. Rivers Run Through Us ends with a discussion of the environmental state of our great rivers and their future, the various threats that they face, from pollution, overuse, and climate change, as well as how we might alter the way we interact with them to rediscover what hydrologist Luna Leopold called a reverence for rivers. To ensure their and our persistence into the future, these great rivers, through which the history of North America has flowed, deserve no less. Rivers Run Through Us, a natural and human history of great rivers of North America, is to be published in the autumn of 2021 by Rocky Mountain Books.
So there you go. That's the book. That's Rivers. That's why I wrote it. I hope you buy it. To be crass, no. It was a lot of fun to do, and I'm looking forward to it coming out. And certainly a portion of any of the profits will be going to river conservation groups, suggestions of which are welcome. So with that, I'd be happy to answer any questions or hear stories that you have about a river that means something to you or meant something to you in the past. Thank you for listening.
So no questions in the chat so far, so maybe I'll ask a couple. And there was some appreciation of learning some of the technical terms of rivers earlier from Nicole. And Nicole also shared the World Rivers Day website as well.
Great.
So it'd be interesting to check out. So I was curious about, so there's a couple of housing developments that are new on the river. There's the river district on the Vancouver side of the Fraser River, and there's a lot of development now just coming out on the Bridgeport side. And I wonder if you had any feelings about all these condos and right on the edge of the river there.
Yeah, well, there's an initiative that some of you may have heard of called the Heart of the Fraser. So the lower Fraser, which I'm calling from Hope down to the Delta, it consists of 3 regions. And the last one is kind of the Delta area. I think they call it the Sand Reach. The middle part is the Gravel Reach, which is very, very important fish habitat and has undergone massive drain. There was a paper recently came out, and I think people have known that the wetland habitats, the vast majority of them were drained or diked or destroyed or whatever over the last century and a half. So there's an initiative called the Heart of the Fraser, which is to, in the middle part of the Fraser, not the part Nancy's talking about, I'll get to that in a second. The middle part of the Fraser, there are some housing developments on some of the islands in that region, and also some commercial development, and they want to put some more bridges to these islands in the middle. So there's a lot of concern about that. And of course, there's a lot of concern about what Nancy's talking about as well. I mean, the lower Fraser River, you know, the Delta area, I mean, it has Vancouver and all the other cities surrounding it. It's an incredibly important area for vertebrate biodiversity, from birds to fishes. And it's just being overdeveloped. And that really is and this is discussed in the book. The Fraser River deals, as the video said, it deals with how the river actually sculpted the biodiversity we see in these BC provincial fishes, the salmon. And, you know, it does talk obviously a little bit about the threats towards them at the end, but really this overdevelopment is kind of the master variable that drives everything, even climate change. If we didn't have overdevelopment and the human footprint, climate change wouldn't be an issue. So this is another one. I mean, I don't have any specific comments about that particular development, only to say that, you know, it's a zero-sum game. The more developments you put in an area, there's no question, the more particularly the riparian habitat and the streamside habitat is going to be impacted. And presumably they went through all the proper approval processes and all this sort of stuff. But the bottom line is we're just chipping away at the habitat, and that's the master variable that's causing these impacts we're seeing now. You know, chronically low salmon numbers in the Fraser River across all the species, basically.
Fantastic, thank you. As Sheila is saying, regarding pollution, do you feel that we have made any progress with cleaning up rivers locally, specifically the Fraser River? And I'm just going to turn the allowing people to unmute them in case people want
to. You know, certainly there have been, you know, there's certainly been local improvements. WWF Canada produces watershed reports where they break each of the major drainages in Canada, including the Fraser River, into, you know, different sections, and they rate it based on water quality, the quality of water and threats to it. And, you know, you'd have to look at the trends to see whether, I can't imagine the lower Fraser's gotten any better over the last 25 years. I think there are local areas such as, you know, some of the smaller creeks that feed into the Fraser eventually, where there have been improvements in water quality. There has been a cessation of some of the inputs in local point sources and habitat improvements. I'm thinking of Still Creek in Burnaby, for instance, where there was great celebration, I think last year, where some chum salmon returned for some time. But you know, we certainly made improvements in a larger context in the Great Lakes, where, you know, acid rain was a huge problem, international problem between Canada and the US. And we basically solved that problem. Phosphorus overload in the lakes, particularly in the Laurentian Great Lakes, Shield Lakes, was a huge problem. We identified the problem, enacted regulations to stop the problem from happening, and the lakes recovered. So you can do it. But those are, you know, those sort of point source pollution things like acid rain or phosphorus, they're and I don't mean to diminish them because they can be very complex, But compare that to human encroachment, which can mean all sorts of other things. You know, it's a much more complex problem. And I think that's, and pollution is not unrelated to that. It's not independent from that, but that's the overriding problem. But to answer your question, I can't really comment about whether the lower Fraser itself, I would suspect it's gotten worse for sure.
Okay, thank you. So Lynn is asking or saying the natural history of the Peace River and now Site C construction is very controversial. How many studies of its natural history was studied and is now being studied for the pre and post construction effects?
Wow, well, that's really that's a really good question. So in the Mackenzie River, the Mackenzie and the Yukon are probably, because they both flow down north, as people in the north like to say, away from major population centers, their water quality is actually pretty good, except in some local cases. But of course, the Peace River, or the Mackenzie River, as was described in a book about it in the 50s, is like a giant majestic canvas spread across 20% of Canada. The Peace River is one of its main tributaries, and it deserves a chapter all on its own, but I didn't do it. I included it with the Mackenzie. So Site C and the Athabasca River is another one that has the oil sands developments in it. The Site C dam is very controversial for all sorts of other reasons, not only just having to do with biodiversity. You know, the biological, environmental assessment was some ungodly number of 700 pages or something. I tried to go through parts of it. You know, it seemed to tick all the boxes, et cetera, et cetera. But I read a very interesting paper, and if you contact me by email, I'll send you, I can't remember exactly the title because I just found it. Oh, it's 2018. And it raises a lot of questions about the veracity of the of sort of the assessment process itself. And the point of the paper was it was kind of rigged, seems to be kind of rigged to have found, that's just what the authors are saying. And there are a couple of UBC professors that was kind of rigged to find, to come to the conclusion that the impacts of the Site C dam would be minimal at best, or they could mitigate them. Now, one of the issues that the authors raise is there are also two other dams on the main stem Peace River, the Peace Canyon Dam and the Wacky Bennett Dam. And cumulative effects, so you can talk about the effect of the Site C dam in and of itself, but what about the effect of the Site C dam given the fact that we have these two other dams already there? What are the cumulative impacts? That was one area that seemed to not get as great a treatment as it should have. Not a very good answer, but I can send you the paper if you contact me. I'll send you I can actually send you the PDF of it. You can read it yourself. It's pretty illuminating.
Is it okay if I pipe in? Yeah. Okay.
Sure.
So Rick, that kind of leads to my question about pollution, and the Site C dam, I think, is going to accentuate this in the sense that if the river flow is potentially going to be decreasing over time here with climate change, and various pollution that is, you know, like I'm thinking about Metro Vancouver, tertiary release of water that has been cleaned, so to speak. You know, as the rivers decrease in volume, will that concentrate? Will these pollutants not become more concentrated and maybe not affect the river immediately adjacent, but certainly the down area, the downflow area? One of the reasons I mentioned this is I remember a couple of years ago that fishermen were saying that part of the problem with the sockeye decrease, well, sockeye and salmon in general, was that the middle arm in particular, where there was logging,
Yep.
that the
Toxins from the log sorts.
Right, that the salmon were virtually not even moving through that middle arm, but actually detouring around it. So that's where I'm coming from.
Yeah, no, it's I mean, not to say, some people say the solution to pollution is dilution. So the opposite of that is the less flow there is, which I don't agree with, obviously. The less flow there is, the less effective is that dilution going to be? It's certainly in the Fraser, that's a huge issue because the water quality in the last sort of 40 or 50 kilometers can get pretty brutal. The Peace River, and decreased water flow is also very important there. If that does happen, well, first of all, it's going to impact the economics of the revenue from the dam, presumably, but also it has huge impacts on the Peace Athabasca Delta at the eastern end of Lake Athabasca, which is a very, very important wildlife area. And there's already been changes to flow patterns from the first two dams and the third dam. Not only the pattern of flow across the year, but also just, as you say, climate change. Although those areas, it's quite possible that headwaters, certainly of the Mackenzie and the Yukon, are going to see more precipitation, but it might come more as winter rain than spring snowmelt, which can be an issue. So yeah, it's probably going to impact the Delta more than pollution per se, because there's not that many people live up there. Although those that do are important.
So just one other thought there. I drove by Sea to Sky Highway the other day, and after the fairly large rainfall up in Whistler area and coming back down, I was amazed at the color of the Squamish estuary and where it opened up heading towards the wood fiber area. Incredible muddy water, and then the glacial white, which is great that water that we got the rain, but obviously a huge amount of sediment was just washed directly off the banks or whatever to cause that color differentiation, and that is apt to be more common, don't you think?
Quite possibly, particularly with I think this year already. Well, it's weird. I mean, we've had a lot of flood events at strange times of the year. We shouldn't be getting flood events at this time of year. Flood events in the spring and maybe in the fall. But it's because of the accelerated. I mean, the Lillooet River was flooding sort of near the end of July when you wouldn't think it would be peaking flows. Peak flows you would think would be about a month earlier. But because of the heat wave, the heat dome, and all that, it just caused this extraordinary melting that caused a sort of secondary flush. So yeah, that's a huge problem. The change in the pattern of outflow of rivers is definitely going to be impacted by climate change. It's going to dry out the West, and the Midwest and parts of the Northwest may see more flooding at bad times of year, and melting permafrost, that sort of thing, accentuated by melting that shouldn't be happening. There were big floods in parts of the Mackenzie and the Yukon as well, a little later than you would normally expect them this year. I wanted to just mention one thing. I mean, this is all obviously important stuff, and part of the rationale from the book was to get people to care about rivers. There's only one chapter where I really talk about there's only one chapter where I talk about the future of rivers, particularly in terms of climate change or large interbasin water transfers. There was this nutty scheme back in the 70s, and I can remember in the old Institute of Animal Resource Ecology seeing the maps of it, called NWAPA, which was a North American Water and Power Alliance, concocted, a monstrosity as some people call it, by some engineer in Los Angeles who was prescient and said, California is going to face a water shortage. There's all these rivers like the Fraser, the Peace River, the Yukon River, the Mackenzie, that are all flowing to the sea, basically wasting the water. Why don't we link them all with a series of canals? We'll build a giant reservoir which would have flooded Prince George, by the way. We'll build a giant reservoir in the Rocky Mountain Trench, and we'll build a canal to the Great Lakes and connect that way so we can get ships coming from the Great Lakes right across to New Prince George. And fortunately, as someone said, as often these giant things do, it would have poured more concrete than all the dams ever built in world history, according to some calculations. And it died as a function of its own grandiosity. It was just going to cost something like $40 billion a year at a time when the U.S. total budget was only 100. I got the figures slightly wrong, but they're relatively correct. The U.S. federal budget was only $100 billion in total anyway. So it died. But there are people, and I discuss this in the book, there are people who are keeping this alive. So you can go to a YouTube site and you can look, it's now called Nawapa 21, which is this sort of weird fringe group that says this is going to come in the future. And as Mark Reasoner, who wrote another very, very influential book called Cadillac Desert, said, you know, we shouldn't be too sanguine about these things when scarcity in the future may make things that seem crazy now quite likely in the future. So it's pretty good. But my point is, the bulk of the book is about different like art or warfare, how people have interacted with rivers and how rivers have interacted with us. And it's that way, other than talking about all the threats to rivers, that I want people to try and care about rivers and appreciate them, so that when they hear about the pollution in the Fraser River, they'll go, oh my goodness, you know, I had no idea that Pacific salmon might have been one of the forces that drew people over from Asia when the ice left. You know, these salmon are so critical to the experience of all sorts of people from all sorts of different places in North America and in British Columbia, and we really should do something about it, because we hear so many little snippets. Sometimes it's harder to see the larger connection. So that's really the goal of the book, is to help people appreciate how important rivers have been to our experience, and that we owe them at least thinking about how to treat them better.
Awesome, thank you.
We've got a couple of last questions too. We're at 5 to 2. This is from Lynn, have the erratic summertime flooding events affected the major upriver spawning of salmon species?
Well, I can tell you from here, you know, it's the lack of water that's the issue. Not really. I've as far as I've heard from the Pacific Salmon Commission, the early Stewart sockeye salmon that come in, I'm going to get the date wrong, but sort of in the early summer, go all the way up to the Stewart River. People are on the spawning grounds. They seem to be doing well. They're at peak spawning. First of all, they made it past Big Bar Rock Slide, and the water levels have not been an issue so far for those fish to spawn successfully. But there may be, like the flood in the Lillooet River, which has some sockeye that go into it up past Harrison Lake. That flood happened long enough ago that it might settle down by the time they're spawning, but I don't know their timing in particular. But it's really a lack of water generally that could be the issue, particularly on Vancouver Island. Oh, and sorry, also, I mean, this is the first year I know they've closed not just one river in the Okanagan. They've closed whole sections of the Okanagan to fishing simply because the water levels are too low, it's too hot, and that's a deadly combination for fish. And I believe in the Kootenays as well. That's the first time I've heard of that.
Yeah. So we have another comment from Nicole. She said, thank you for a great talk. And she also wanted to answer your question about her favorite rivers. So spent some time on the North Saskatchewan last week, and rivers always a reminder of connections, power of water, and how nothing stays the same forever. Let me just check to see if
life is ever changing.
Yeah. And then Armando says, what is the river you have not traveled to yet and are just itching to see?
Oh, that's a very good question. Well, you know, I'd be, geez, I could think of 3. I'd like to see the Congo River, parts of that, because I really loved Heart of Darkness by Joseph Conrad. Oh gosh, there's so many. But certainly the Congo would be one, and the Amazon would be a natural for sure.
Yeah, fantastic. Yeah. And I think we're nearing the end of our time. Did you want to end with maybe telling us how your experience writing the book was, and then maybe any last thoughts that you had that you wanted to end with?
Well, the most important one, of course, is that it's available for pre-order on Amazon.ca or your local bookseller, which I would encourage you to go to the local bookseller. You can pre-order it to make sure you get a copy, and I'm happy to sign it if you want, that sort of thing. We're hoping to have a book launch at the Beaty Museum in early December, first week of December. So we'll hear more about that then. And yeah, here's an interesting statistic. So I came up with the idea on a canoe trip, although it'd been percolating for a while. And on the last sabbatical I went on, 2014, 2015, I wrote about 45% of it. It took me 5 years to write the remaining 55% of it. So it took 5 years, but it was really, really enjoyable, particularly doing the research. I hated the copy editing and finding yet another error in the proofs. My God, that just drives me crazy. Those of you who publish scientific papers, you do that for a 10 or 12 page. Imagine doing it for a 485 page book. There's bound to be an error in there that I missed. So that was really frustrating for me. But it's a great thing to do. It was a lot of fun. Basically I wrote it for myself. And Tony Sinclair told me to write it and worry about getting a publisher later. And he said, if you write it for yourself, other people will probably like it. So there you go.
Great. Oh, and can we pre-order the book through the Beaty Museum or the UBC bookstore? Just the.
If you go to Maggie and tell her I sent you, I put her down for 150 copies and she yelled at me that that was too many. Yes, you can definitely pre-order it through Maggie. If there's any issue with it, tell her to contact me and I'll set her straight. But don't tell her I said that.
Okay.
Yes, you can. Yes, you can.
All right. Thanks, Amy, for that question. And thanks for mentioning the Congo as well and your favorite fish. So I wanted to thank you again, Rick, for joining us today and sharing this, your experience with the book and rivers with us. And so I'll just finish off with the
Great.
last.
Well, thanks for coming and for the good questions.
And if anybody is interested in supporting the museum, there's a couple of websites there for donations and membership. And we just want to thank everybody for joining in with us today for our last Beaty at Home. Thanks. So you can go ahead and hit the leave button if you want to leave the meeting. Just go ahead.